Welcome, everyone. I'm doing this blind. For some reason, I cannot see the stream. My name is Achùcarro. I've recently become the teaching director for the Masters in Physics in Leiden. I am joined today by Rafael van Laak, who I hope you can see, and Carlijn Kruiswijk, which is a very difficult thing to pronounce if you are not Dutch. I'm not Dutch, as you can tell. So I think that's probably the most difficult thing I will have to do today. Is there any, Rafael, can you signal to me at least whether you can all see me and the live stream is, the three of us are visible?
I can clearly hear and see you, but okay. With regards to the live stream, then your guess is as good as mine.
That's okay. Okay, so then let me just tell you something. The first thing I should tell you is that I am a theoretical cosmologist these days, but I think perhaps a better way to describe me is I'm a theoretical physicist by training, with a history and other things like black holes and solitons and supergravity and whatnot. And I'm not very different from other people in Leiden who have histories of moving between fields and doing the things like that. The first thing that you always want to know is, I really cannot see are you seeing the first slide or the second slide?
I'm seeing the first slide.
Okay, so then I cannot move. My slides are not moving. Well, can you see anything?
No, it's still the first slide.
Still the first slide. Okay, so then we have no presentation.
I can take control and perhaps I can try to
try to move them. Okay.
Let me try that. Right, so this is the second slide. Can you see something?
Yes, so I think we are all here because we love physics. We want to know how nature works. And what we do in Leiden is we always try to go a little bit deeper, a little bit more fundamental, and that makes us very flexible in terms of the type of problems that we can attack. It's always across disciplines and with very blurred lines between what is considered theory and what is considered experiment. Can you please move to the next? Yes. So we have a master's in Leiden, which is, is basically reflects all these ideas. Leiden defines itself as a research university, so we are indeed at the forefront of international research in physics worldwide. But what is a little bit different in Leiden, perhaps, is the level of interdisciplinarity that we have across the different groups and across the different research areas. You will understand in a bit what I mean. Also, our motto is theory meets experiment, or if you want, it could be theory meets experiment meets theory, because we really blur that distinction and we try to physics is physics. And if you need to write equations, you write equations. And if you need to build an instrument to measure whatever it is that you're trying to measure, then that's what we do. And we do it very well. In terms of how does it feel? Well, we have a master's which is as personalized as we could possibly design. It has flexible training. It has a very good feeling of sort of a small scale operation. You're never in very large groups. The groups are small. We talk to each other all the time. It's very international. If I think of, I'm in the theoretical physics department in the Institute Lawrence for Theoretical Physics. And there we totally outnumber the Dutch in terms of staff, for sure. And once you go to PhD students and postdocs and whatever, English is the language of choice. And the other nice thing is that, of course, you as a student in our masters, you will be one-on-one with really top researchers. You will sort of have lunch with them, dinner, whatever. But now, because of COVID, which is, it's unfortunate, but we are really looking forward to the light at the end of this tunnel. Last year, we instituted the system of tutors, which is this year it was 3 tutors who were taking care of any problems related to, maybe your background is a little bit different if you studied, if you're coming from abroad, or maybe you did something some years ago and you don't remember it very well, or for whatever reason. In those cases, you have the tutors who are ready to correct whatever problems you have, and on the one hand, and on the other hand, they're always ready to sort of take you further and give you the bird's eye view of what's happening in the courses, between courses, and all these things in small groups. So the groups could be as small as 3, 4, 7, depending. Sometimes bigger, of course, but the point is that everything is flexible and everything is designed so that you can have the best training possible. And Leiden is a research university. So the moment you start your research projects, which are a very important part of your master's, it's in the research master's, it's 50% is research. You are immediately embedded in a research group. You are one of us. You could as well be a PhD student. You're sort of a PhD student in the making. But of course, you can access everything that we can access. So we welcome you completely. Can you please, yes. And, I don't know what you know about Leiden. If you're Dutch, maybe you know more, but for those of us who came from abroad, the list of things that were invented or discovered or dreamed up in Leiden is really, really amazing. And everybody knows about the Leiden jar, the first condenser, but the microscope, the refraction law, the Snell's law, superconductivity, superfluidity were discovered here. The accelerated universe was discovered here. Black holes were first written here. The Zeeman effect, of course, was Peter Zeeman, who was here. He got the Nobel Prize in 1905. But everybody's heard about Lorentz. And I don't know whether you even know that radioastronomy was born from a quantum mechanics calculation that Henk van der Hulst did, where he discovered that there would be radio waves detectable, and that's what radioastronomy works with these days. It's the hyperfine transition in hydrogen. So we have a lot of weight on our shoulders in some sense. Rafael, can you change, please? Yes, and the tradition continues to this day. You can any metric that you use, we are always doing fantastically. And this is one of many metrics, which is a very, very famous prize for Dutch people. For foreigners, it's not so well known, but they call it the Nobel Dutch Prize. And so we have 4 winners until very recently. I think we were, it was a record for a physics department to have 4 Spinozas. I don't know whether this is still the case, but we're certainly very, very well, doing very well in this regard. Rafael, could you, next slide? Thank you. Now, I told you I'm a cosmologist, and for me, this picture has always been very inspiring. This picture sits in our main lecture hall, not during Corona times, of course, but we forget about Corona because we hope that next semester we're going to be back on our feet. And this big picture is always looking at you while you're lecturing. It's like, okay, watching over your shoulders that you're doing things. And what I always find inspiring about this picture is that if you can recognize Einstein for sure, and probably Lorentz as well. Ehrenfest is the smiling guy in the middle. But what's nice about this picture is that it has 3 physicists. So Einstein, Ehrenfest, and Lorentz were physicists, and 2 astronomers, Eddington, who made Einstein famous with the eclipse that proved general relativity, and De Sitter, who maybe you have heard of by now, who was the director of the observatory for 18 years, and he was one of the first people to work with Einstein's theory even before it was published in its final form. Both Lorentz and De Sitter were already working and doing calculations with it. And that's remarkable. Turns out that De Sitter's solution was the solution for an expanding universe which is empty with a cosmological constant. And so if our cosmological knowledge of today is correct, that is where we are going. We're heading towards a De Sitter universe. So, important things again. What I found very inspiring is having these people from different fields talking to each other, working together, collaborating. And this inspiration is what led us to start a new master's in cosmology, which continues to this day, and which we do jointly with the astronomers in the observatory. So it's one example of multidisciplinary things that we bring directly to the students. Next slide, please. So let me give you a quick overview of how research is organized in Leiden. You can see there are three main research areas. We have the biological and soft matter, quantum matter and optics, and cosmology, which by the way wasn't there when I arrived here 20 years ago, but now it's a very strong component. Different scales, different technologies, different everything. Next slide. And of course, theory that straddles between the three of them. And that's how we keep, oh, sorry, can you, well, it's okay. That's how we keep things connected. The theorists are flexible enough that they can talk to everyone and make connections where, they facilitate connections that might not be so easy otherwise. Can you, next slide, please? Yes. So the most extreme example that I can think of of what happens in Leiden that really shows what it means to be in Leiden is our group where string theory meets superconductivity. If you have these three people here, Konrad Schaum, who is a string theorist, Jan Zanen, so is a very famous condensed matter theorist, and Milan Allen is a condensed matter experimentalist. And the thing about string theory is that it allows you to attack a problem which has been very elusive for many years, which is high TC superconductivity. We would like to have superconductivity at high temperature. And nobody understands exactly how that works. There are some materials that are superconducting at 100 and something Kelvin. But, if you want to control nature, you need to understand it. And this has stumped physicists for decades. And so what string theory does is it brings some of the questions that you're trying to understand that you cannot attack with the normal, with your usual tools. Somehow it converts it into, it maps it into a completely different problem where you're dealing with a black hole in a space which is, by the way, called anti-de Sitter space, because it's related to this space that de Sitter wrote. And that's where you do your calculations. And then when you've finished your calculations, you translate back to try to learn something about systems like high temperature superconductors. It's a sort of broader class, but it's an amazing idea. The fact that general relativity has something to do with condensed matter physics, and it's a very new idea. It really shows you that theory and experiment work together, and it shows you that different areas and different expertise can join to solve a very difficult problem. Next slide. You want to solve something, you probably need to design something to help you with your problem. We were in the news not so long ago because we had the world's smallest boat 3D printed in Leiden, and that was done in Daniela Kraft's group. And they say, well, why would you do this? Well, of course, what they were trying to do is they were trying to understand how micro swimmers, such as bacteria, would move things. You're a physicist, so you're trying to separate things like how does the size influence the swimming, how does the shape influence the swimming, or the fact of how far you are from a boundary in your channel, something like that. And they're trying to separate all these things and understand them and put them together so that you can manipulate things. But this was a nice little example of, you need something, you make it. Next, please. Another Leiden. So in Leiden, we have experimentalists who are very, very busy trying to create states which are some halfway between quantum and classical, so that you can understand really the collapse of the wave function and this transition between quantum and classical behavior. And here are two. And again, you can imagine that they talk to theorists all the time. So, it's another nice example. Next, please. And another new kid on the block, Martin van Hecke now has a very famous, world famous group making mechanical metamaterials. So metamaterials are things that you control. That they are designed to do whatever you want them to do, and that's not necessarily what they would normally do. I mean, if you imagine a slab and you press, normally the slab becomes fatter on this direction. And this material that you have here on the picture does exactly the opposite. When you push, it becomes thinner. Why? And well, so that's the question. Why? How do you control this? You know, what are the equations that describe this? And so in Martin's group, they do even very sophisticated mathematics to describe all these processes and how to, with the idea to design better materials. Next, please. Okay, so how are you? Let me get to the research masters. You have the 4 blocks, and each of those 4 blocks has a master's. There's a master's in biological and soft matter, or in quantum matter and optics, in theory, or in cosmology. Next, please. And as of this year, there is a new master's, which is dealing with data science. And of course, data science is something that's important to all of those areas of physics. So the master's is called Classical Quantum Information, or rather Research in Physics, Classical Quantum Information. And the idea in this master's is that you can either take it in the direction of quantum computers, quantum algorithms, all these new things that are happening now in the very near future that so many people are busy with, or you can take them in the direction of big data, machine learning, and all these things, or in the combination, and and then you can apply it to any branch of physics that you want. So if you look at the research projects, next please. In this new branch, those 6 people, so one is a computer scientist doing quantum algorithms, the first 2, the second one trained as an electrical engineer. Carla Skelly is a physicist who teaches a course in econophysics and works with banks and with all sorts of things, understanding correlations and things like the crash and how networks work internationally. Sant Leben is a particle physicist, an experimental particle physicist who's building a neutrino detector in the bottom of the Mediterranean Sea. And the amount of data that they get is so huge that they cannot even send it to shore. They have to immediately process it before they do anything with it and lose lots of it. So it's really, really important to understand what you're doing. Schaller is a computational cosmologist, an absolutely state-of-the-art computations in cosmology. Sembrau is a biophysicist. So it's it's a really interesting offer that you get if you take this master's, and we think it's going to be fantastic. All right, so this is the research master's. Okay, I'm seeing a question, but maybe we'll deal with the questions in a little bit later. So I'll just Jona, hold it there for later. So these are our research masters at a glance, but of course, next slide. We have one extra dimension. If you imagine, so the research masters, this is sort of the direction outside of the screen, which is that you can do any of those, but with a slightly different idea that if you want to try even more things, then in Casimir you get the chance to do different research projects, even more so than in the normal masters. So there's a tremendous flexibility in how to design your project. The Casimir is done jointly with Delft, and it's something that you cannot, you have to wait until the first semester before you can be accepted to it, because it requires some minimum grade. But it prepares people for a PhD in whichever one of those areas, but in a PhD, and is particularly interesting to people who want to work with between Lyon and Delft, say. Next, please. Well, no, research is all too well, but we are not in an ivory tower. This society has many other uses for physicists and needs for physicists. Physicists go into business, they go into education, they go into communication, and we do have a master's that covers, in fact, 3 masters that cover all this area. Next, please. But of course, next, yes. But of course, we've designed a master's which really joins research with business, research with communication, or research with education. And so that in Leiden, again, because we always try to go deeper, we try to go to the fundamentals. The fundamentals mean that you are flexible and you can move in different directions, even at this level, at this society level. Next, please. The 3 masters that are not the research masters, shall we say, they have 3 different coordinators, and I'm sure you know them. You can find them in our websites. Next, please. So here is the program structure for all the possible things that you can do. And what I want you to notice is that anything in green means research projects. And you can see immediately that, so that the top 5 are the research masters, and they basically have 50% of research. Your second year is just devoted entirely to research, but you always have to do at least 2 projects, except in theory, where you have a 1 longer project and some special courses that you take in combination with Utrecht and with Amsterdam. The other thing that I would like you to notice is that the core courses are a very thin part of your portfolio. We have 12 ECs of core courses, and what is important to emphasize is that these core, we are physicists. We believe that all physicists should know some quantum and all physicists should know some statistical physics. And so regardless of your specialization, you will have to take at least 1 course in quantum and at least 1 course in statistical mechanics or something equivalent. Okay. And then, of course, the light yellow is, depending on your master's, you may need some extra material, some extra courses which are relevant to you. But blue is what you can select, and as you can see, there's a lot of margin of maneuver. Okay, you can really build your own curriculum very often. For the 3 non-research masters, so physics and business science, physics and science, communications and society, and physics and education, then the structure is a little bit different. You have 1 year of physics and 1 year of, business science or communication or education. And in both the first year and the second year, you have a very strong practical component. In the first year, you have to do a research project, which takes more than half of your time. And in the second year, you have either do an internship or a project or some practice with teaching, whatever. Those are the things in brown. And any questions, of course, we can deal with either in the chat or later on. Next, please. This is the same thing again. On the left, the research masters, and with a little bit more detail of what courses are the core courses. They're a little bit different for cosmology, but it doesn't matter too much. The idea is the same. And the core courses, so on the right, you have the non-research, the structure of the non-research ones. Next, please. So I hope I have convinced you a little bit of what we have in mind in our masters. We want you to be one of us. We want you to dig deeper into how nature works, how we express this with equations, and how do we use this to manipulate nature. And for the rest, you're free to design your own story. Next, please. And a few final words about what life is in the Netherlands. We move by train. Trains are very good. And of course, by bicycle. Everybody knows that. And the thing on the left is beautiful. Those are the flower fields. In about a month from now, we will all be getting on our bikes to go take a look at the flower fields ourselves. Leiden, the city of Leiden is small, is beautiful. It has the center becomes It has a Saturday market where you can find absolutely anything. We're famous for cheese. We're famous for haring, the fish, which is herring in English. And it's just a very nice way of life. It's not hierarchical. People are welcoming. They are, I don't know. As a foreigner who settled in the Netherlands, I have to say I'm very impressed with the way of life here. One more thing. Next, please. Regarding life at the Institute and the atmosphere at the Institute, we have a bunch of colloquia, but we always have a lot of people visiting, going through. And the thing is, you get to talk to all of them. So, for instance, the Ehrenfest Colloquia is something that has been going on for more than 100 years. We celebrated 100 years in 2012. It's a series of colloquium that happen after dinner on Wednesdays, a few per year. And the gimmick is that once so first you have dinner with the speaker, then the speaker gives a talk, and then they sign a wall in pencil. And if you look at this wall, we have the old part of the wall is in our main hall. If you have ever visited Leiden, and yeah, you can find the who is who of 20th century physics. They all signed this wall, and it's really good fun to look at them. This is also on internet. You can also do your own searching on internet, but it's a lot of fun. And the tradition continues, and we like to have, we have phenomenal scientists, and every now and then they're not only phenomenal scientists, they're also sort of superstars on the social media. And so we had, a few years ago, we had Achùcarro, who I'm sure all of you know, but also Ed Copeland, for those of you who are following 60 Symbols, he was... he's a good friend of ours, and so he was also, besides being a superb scientist, he gave a fantastic colloquium. So you get to have dinner, you get to talk to them, and everything you want. We also have Lawrence Professors, which is once every year the Institute of Theoretical Physics has a special chair. And they come for a couple of months and they interact with everybody, and it's great fun to have them around. It's really, really very nice. We have the Van der Waals Colloquia, and so I'm going to finish this with just one very important Dutch concept, which is the borrel. And the borrel is the beer that you have at the end of the day, or at the end of a week, or at the end of a talk, or whatever, where you walk around and you have some drinks with your pals. And that's really very Dutch, and the first word that you need to learn when you come to this country. Next, please. For the rest, Leiden is stunningly beautiful, very international. It's a student city, and it will welcome you with open arms. And finally, final slide. As you know, at 1 there will be a chat where you can ask any other questions that we cannot deal with today. But here is our study advisor, Hara Papatanasiou, and she will be at the chat, and you can always contact us, email us, or whatever. And I will stop here. Back to Rafael, I think. Unless you tell me that there's a question that we should answer right now, I would defer questions until he and Carlijn have finished.
Yeah, there is one question about the way that you can structure your master. But if you wish, we can save that for later.
Okay, sure. I mean, the chat is certainly can answer all these questions as well. Go ahead.
Okay, so I'm gonna leave these slides on the background just in case we need them later, but I'm not gonna use them. Yeah, so my name is Rafael van Laak.
You can show a different face.
Oh, sure.
There's Hara.
Yeah.
Hi, Hara.
Hi. But I'm here to answer questions. That's why I interrupted you. So I'm gonna stay on a bit at the end if we have time. Also
fantastic.
for questions.
Okay.
Great.
Very well. Is this a good slide to leave on the background?
Oh, anything you want.
Okay. So I'm a master's student at physics at Leiden, and I did my bachelor in Leiden as well. But I actually didn't do a bachelor in physics. I did a bachelor in astronomy instead. But as I started to reach the end of my bachelor, I began to realize that I wasn't really cut out for observations and was far more interested in theory. So the way that I always see it is that astronomy is always more about answering the question how the universe looks like, whereas physics is more about answering how the universe actually works. And that's of course a bit of a broad generalization, as there are also many cases in between. But this is always how I viewed it, and I definitely prefer the latter. I definitely prefer theory. And so it is for that reason that I decided to switch to a master in physics. And right now I'm doing the cosmology specialization specifically. So in case there are any of you that are astronomy students at Leiden, know that it is very easy to make the transition between astronomy, between a bachelor in astronomy and a master in physics. There is really no difficulty or difficult bridge that you have to cross if you wish to do that. I don't actually live in Leiden. I live in Rotterdam. But one of the things that Anna already told you is that trains are very easily accessible, so to speak. Even though Leiden itself is a small city, a relatively small city, you can quickly hop on a train and go to any of the other larger cities in the Randstad, which is the urbanized area in Holland and Utrecht. If you want to spend a day in one of the larger cities, you can easily do that. And I can only confirm that by saying that I always used to make the trip from Rotterdam to Leiden every morning, which was less than a 30-minute train ride, so that's easily doable. So when it comes to the structure of the courses and the program itself at the Master in Physics, you will notice, as Anna already showed you, that there is a very large amount of specializations and a large amount of courses that you can choose that you can choose between. And what's really an advantage of that is that, and you already saw the graph of the amount of courses that you have to do and everything, that you have your set of mandatory courses and you have a set of elective courses that you can choose, but are still related to your specialization. There is still, at the end of the day, a large room for courses that you can follow, that you can really choose yourself. So you can, of course, choose to follow a set of courses that really lies within your specialization. But if you wish to broaden your horizons, you can easily follow a number of courses that lie outside of your specialization. And well, regarding the specific courses, there are your regular courses that you would come to expect in a Master of Physics, like courses on quantum field theory, courses on general relativity. But there are also a large number of far more specialized courses that really discuss a single specific area in much greater detail. And many of those courses are 3EC, so you also have the opportunity to elect a relatively large number of those courses. The students that you will meet during your studies really have a serious attitude towards their studies and also towards physics as a whole, more generally, which has always been very motivating to me. So a couple of examples that I could give you, for instance, is that at the end of a lecture, and again, this is something that, of course, is more relevant to the time before the lockdown and before the pandemic, but hopefully after the summer, this will be again the case, that you will actually follow lectures on the university. But after a lot of lectures, there was always a group of students that would walk up to the front of the blackboard and discuss some of the material that they just learned in further detail. So they would pick up a piece of chalk and evaluate some of the equations and really further discuss in further depth what they just learned during the lectures. And sometimes even the professor would join this discussion. And Another thing that you could do is if you're having a break and you're having lunch in the canteen, again something once the pandemic would be over, but still the general idea remains the same, that you can always join a table where a group of students is sitting, and you can always have some discussion about some theory of physics, or about some of the courses, some of the lectures that they followed, or some of the research. There's always something going on, and there is always a discussion about that. So all of this shows that students really have a interest in what they're doing, and that they really have an interest in physics, and are not purely focused on getting their ECs and passing the courses just for the sake of the ECs, but also really because they want to learn about the things of physics that interest them. So even though students are always serious about what they're doing, there is still a very informal atmosphere between students that will always allow you to ask for help if you're encountering some problem, if you don't really understand something about some of the lectures or some of the problems. You can always ask one of your fellow students in the group chat or whatever, and there's always someone kind enough to help you out. And even if it's completely unrelated to your studies, unrelated to physics, for instance, if you want to know something about the university, know how something works, something related to exams, or if you're looking for a building or an office that you can't find, then you can always ask that, and there will always be someone who can answer your questions and help you out. And you will recognize the same pattern with professors and their teaching assistants at Leiden University. They're always easy to approach outside of the lectures. If you want to ask something, ask some clarification about the lecture, you can always send them an email, or if they're at their office and available, you can come by them, and they'll be happy to answer you. Of course, during lectures you can always ask questions, but perhaps you don't really feel like that because your question would be too difficult, or your question may be too long. You can always approach the lecturer in the break in between the lectures if you want to have a bit more of a personal discussion about the things that you were wondering about. That's something that you can always do. And another thing to really appreciate is that professors are very flexible with schedules. If it turns out that you and a lot of other students have a very busy week and you're stuck up with deadlines and on essays and homework and perhaps exams as well, you can ask a professor if he or she could perhaps delay the deadline for a week or so. And usually they'd be happy to do that if it's within reason. So that's a thing that I really liked, and that really helped me out from time to time. And one final thing that I could mention is that if this is something that you decide to do, that the university really encourages you to become a teaching assistant yourself. So if you want to do something extra outside of your curriculum, but still related to your studies, you can always help a professor in teaching a course. So that is something that you can apply for, and master students are very often hired for such positions. So that's all I wanted to say. Unless there are any questions regarding my discussion, perhaps we can move on to Carlijn.
Yeah, sure. I can tell you some things about my experiences with my master. I am Carlijn Kruiswijk. I am doing the Casimir pre-PhD right now, and I am living in Leiden, though with Corona I've basically moved back with my parents. And just like Rafael, I also did my bachelor's in Leiden, only I did physics and astronomy. And in the end, I did choose for physics for my master, mostly because I found that it catered more to my interests. So I was really curious about how things worked, and less curious about the really the stars and planets themselves, and more like how, like at the beginning of how it all came together. And I also liked quantum physics, and that's less astronomy than that's something you do less in the astronomy master. So I first started by doing the theoretical research track, and then after the first semester, I was invited to do the Casimir track, and I took it. And I did that mostly because with theoretical research you only have one large project, but with Casimir you could have 3 projects, as Anna already told you, and they actually have to be at different groups. So what you really get is a really diverse view of all the research groups, which I personally really liked because I didn't really know. I liked studying and learning, but I didn't know what kind of subjects I really wanted to become, an expert in. And yes, this allows me to really find what I like myself. And for that, I've already finished one small project on quantum matter with Jan Zane, who you already saw in the slides. And I am currently doing a cosmology project under Subodh Patil. And I like both of them, so I haven't narrowed my choice down. But yes, I really like doing those projects, and also the difference between the two is very large, but I'm still able to do both, which I find very enjoyable. So the first year courses for me were enough to be able to go in these quite different directions. And actually one of the courses that we have in the first year, which is theoretical research topics, that actually gave me the idea to go to Jan Zane, because I didn't actually know I liked the topic of quantum matter, but through that I found out I liked it, and then I asked him, could I do a project on that with you? And that's how I came to be. And even there in the projects, what I like about it is that there is really flexibility. So with my main project, we basically, the first month was me figuring out together with Subodh how this project was gonna go. So finding out the background knowledge, then seeing out what of this new stuff I learned do I like best to further research, etc., etc. To now I have a very nice research topic that I really personally really like. For if you're wondering, it's basically trying to change quantum fields models into classical field models, which are way easier to calculate. And the same happened in my small project under Jan, where I started on one project with trying to model a quantum gas, and ended up with some project on the thermalization of quantum systems through a wave collapse, which definitely wasn't where my project started, but through discussions, through basically evolution of research, you really find out, oh, this is very interesting. And what's also very nice about that is that you're definitely not on your own with your projects. I have a lot of support, especially also for my supervisor, my professor. With Subodh, I'm having weekly one-on-one meetings to discuss my progress and my troubles. And with Jan was similar, that I could just send him an email and we'd meet on Zoom and talk about it, because it's Corona. And for that group, we even had a online coffee hour where basically we'd all meet on one site to talk about our day or our projects and discuss these different things. And yeah, that's very nice, because you can also then learn what other people are researching and discuss that, and really learn from each other, which I really enjoyed. And yeah, that's basically what I like about it. It's a very nice community where everybody wants to learn and wants others to learn as well. And yeah, you have a really diverse group. So I still have one project to go, which because of Casimir has to be an experimental project. You have to do one theoretical project at least and one experimental project at least. But I'm still planning out on where to do that, so I don't know yet. But yeah, there are still so many possibilities, and I know wherever I go, I will get the support and the ability to basically make this research my own, instead of having like, oh, this is what you're gonna do, this is what you're gonna, this is your planning, and do it. We'll see you at the end of it. It's instead of that, it's really, you know, your own thing that you discuss with other people and really organically work out, which I really love. Yeah. So, yeah.
Very good. So thank you very much. And I don't know whether we should be, are there any questions that we should be answering? Or if you have questions, you can put them on the chat and they will get passed to us. So I'm actually tempted to ask you, how are you doing with the Corona thing? You know, I realized this morning that for me, today, exactly 1 year ago, is when Corona started. That is the first time. So we had a dinner with a visitor who had given a talk, and we were going to go together to with a bunch of colleagues, and we didn't dare. We canceled that, and it was the first cancellation. And after that, I haven't been to a restaurant since then. Of course, still waiting for things to open. But yeah, I'm just I'm at home, but I'm wondering how you're doing.
Yeah, I'm right now doing fine. I had with the beginning of the year, I had my project. We were still able to have physical group meetings once a week, which was very nice for me, because then you actually, see the person and be able to talk to them beginning, and which helped when we then went over to online.
Mm-hmm.
And also for when I started my long project, we were able to still, with masks and distance, be able to meet in person and, figure some things out on blackboards together, so that I really knew what I was talking about. So that really helped. And yeah, now I am at home with my laptop, but I know that I at least have some base to build on.
Yeah. I think lots of people manage to meet somehow and to continue to use blackboards and discussions in one way or another. But by the way, I cannot see the question that was asked before, so I don't. If one of you can see it and can tell us, because somebody had a question and we should.
Yeah, sure.
Yes, someone asked if it is possible to combine, for instance, the quantum matter and cosmology focus.
Well, that depends on what you mean by combining the quantum matter and cosmology focus. If I tell you that in that slide where I showed you string theory meets experiment, the string theorist, who's Konrad Schalm, is also a cosmologist.
Yeah.
So if you're going to be doing, cosmology, do you do cosmology looking at the cosmos? And my work, for instance, is I work on the first fraction of a second after the Big Bang. I'm trying to understand what particle physics looked like and what fundamental laws of physics were like in the instant. And the way we do it is so you do a million calculations and then you look up with the telescopes, because the information is still there, which is remarkable. It's completely unexpected, but there is information in the cosmic microwave background, for instance, as to what was happening a fraction of a second after the Big Bang. And I really mean 10 to the minus 36 seconds. So that's, that's remarkable.
Yeah.
So perhaps
we use our expertise. I mean, so the expertise that you would use in quantum matter and in cosmology, certainly in my case, it's field theory, and that's the same tools for both. So can you combine? Yes. The only thing is you will be a master's in one or the other, but in fact the factor you can maybe take a research. It's possible to do things across. Yeah.
Can I add something?
Yes.
If you look at the structure of the specializations, they're different. As you have heard from Caroline, she's actually combining the two worlds. But Caroline is following the Casimir plan, where you can do more projects, and there is a lot more freedom there. And there is also the expectation that you mix you do experimental projects and theoretical projects. What Anna just described is you may find a particular project when you're inside the theory specialization that combines the two worlds. If you are to do a pure cosmology specialization, then the structure is quite different. You need to do two projects that are of equal weight, and you need to follow a number of mandatory courses. So if you start on the cosmology, then with the exception of probably doing a project like what Anna described, one of the projects, then it's hard to think how you would combine, for example, quantum matter and cosmology. If you do the quantum specialization, then the expectation is that one of your projects is basically experimental. Then again, the other project may be a mix, but then you're looking again into what more or less what Anna described. So there is flexibility, but you need also to look into the structure of the program, and then maybe decide on to go along with a specialization that would allow this flexibility. So different specializations allow for a bit more flexibility when it comes to the project. And in particular, the Casimir actually encourages as much mixing as possible, but it is only for people who have completed the first semester with very good grades. And
yes, actually, there's another possibility, which is if you take the classical and quantum information masters, you could do something in the quantum direction, which links directly to quantum matter and quantum computers and things like that. And at the same time, you could do some project with some large data set or some very large machine learning, whatever, for cosmology, and they would both fit. So, I mean, again, as Harai is saying, you have to look really into the structure of the different specializations, and you have to. I mean, the room is there, and we can help you find the room, but you have to be in the right place, so to speak. So the different specializations are different between them. There was another question about the core of this classical and quantum information.
Yeah.
So if I understood correctly, is what are the core courses?
Yes.
So
and what does the internship mean?
What does what? Sorry.
What does the internship mean from that specialization mean?
Yes. Yes, so this new so let me first tell you what the core courses are. So you have the same 12 that academic and professional skills, quantum information and statistical physics A. Those are as always. In this case, there are 3 courses that are specific to this specialization, and one is the Introduction to Machine Learning, which is given in computer science. There's a course called Physics and Classical Quantum Information, and there's a course in computational physics. And so those constitute the core of this particular specialization. And then when it comes to the research projects, there is remember that I told you that we have a new course that is econophysics. And so the possibility of the internship is designed because, I mean, we know historically that there's a lot of interest to maybe do something with econophysics together with maybe with a bank or with some some national institute, and so there you have the opportunity to do a longer project and a shorter internship as well, and that's specific of this particular specialization. So yeah, sorry, I can't see the whole. You have to read it to me.
One more thing.
Yes, please.
So in general, if you're interested about the structure of the programs, like what the mandatory courses are, you can find them on the course and exam regulations that are accessible via the website. So maybe it's a bit too much now to be taking notes on what the mandatory courses are, but you can find them on this document. So the structure of every specialization is there. So and this applies to all specializations. So this is like, a tip for everyone. And then, the internship, maybe it's easier to understand it as just a project that can be done outside the department as well. And this is the case with all specializations that have 2 projects. So quantum matter and biosoft. The structure of these programs are 2 projects, and when you have 2 projects, it is possible to do one of them outside Lyon. And sometimes this can be a company, and companies like to call these internships rather than research projects.
Yes.
And but for also, the rest, of course, it's just another project. Yeah.
Sure. And I was also going to add that, of course, if you're doing the specialization which has to do with business studies, then that, of course, is also an internship in some company and whatever. Is what Hara is saying. It's a project, but it's a project that you carry out in a company somewhere.
Yeah, but this is different because the internship in this case is with the business part, and then the focus of the internship is on the business skills that you have acquired in the second year of the training. While the physics research project under such a master's, under the science-based business masters, is a project inside the department.
There was another question. How does it work when you want to apply to start in February? Are there any things to keep in mind for that? And does it happen often that people start in February?
Can you say again? Or is Hara wants to reply? So I didn't hear
reply. Yeah. Okay. So if you start in February, in general, you should not start in February. That's the short answer. We don't encourage starting in February because the core courses of all specializations are offered in the fall semester. So you only have a normal progression in the masters if you start in September. You can start in February in some cases, and this it does happen for maybe 1 or 2 people every year. And these are usually people who have completed their bachelor's in Leiden. So if you are one of them, then we can discuss it. You should get in touch with me. But in general, it's not possible. Now, because it remains a formal option, it means that formally you can start. But in this case, you should not expect that you can finish the master's in 2 years. It's going to take you longer. So it would be 2.5 essentially. Which, if you are if you're coming from outside the EU, it means quite a lot of extra money in tuition, and of course, even if you are Dutch, it means an extra half year.
Okay. Yeah, there came in another question. What would you say is the main difference between the Master Physics in Leiden compared to equivalent masters at other universities? So what makes Leiden stand out compared to the other universities?
Well, I think that's what I was trying to explain in my presentation. Okay, so what in Leiden we are focusing on how, and we are focusing on why, and we are focusing on understanding things at a slightly deeper level. And this slightly deeper level gives you, because physics is universal, gives you this flexibility to be able to attack very different problems. So we want you to, so we're not so interested in taxonomy and in knowing lots of details about this or that. We're really interested in profoundly how, what's behind what you see, and how can you test your ideas, and how can you somehow manipulate nature in this way.
Yeah, it's basically like, instead of just saying we have this thing, it works, and we're just going to use it, we're like, okay, we have this thing, it works, but why does it work? And if we change it differently, would it still work? And then you're basically more focused on that instead of actually, the outcome.
Mm-hmm. That's right. So we actually open it up and try to look inside and all these things. Yeah.
I'd like to add something to it.
Yes.
Of course, this is the thing that can help you distinguish between Leiden and the masters at any of the technical universities. So what we call what you might know as polytechnics, right? So if you were to look into Leiden, for example, compared to Delft, that would be the main difference. Of course, there are other universities where you have groups that are actually looking into, taking things apart and explaining how they work. But when it comes to a master's, to choosing a master's in the Netherlands, I think the zeroth order approximation is that in general, they are 2-year masters. They are focused on research. Okay. Then you should look into the kind of courses that are offered. And at this level, I don't know, and I don't know if Anna knows, but you may have slightly different courses in different departments. The main criterion for you to choose, I think, is your particular interests in research. So what Anna presented is the kind of research that is being carried out in Leiden. If your interests lie somewhere totally elsewhere, something that is not covered in Leiden, then you should be looking at this other place. But these are the selling points of every master's. You should go to the website of every university, and look at the research pages of the staff members. And where you find the research interesting, engaging, then this earns extra points. So this gives you more of a direction. But for the rest, if you're looking from outside to the Netherlands, I bet all the cities can claim that they are nice. I mean, the Dutch mentality is a given. And then, the course programs and the structure of the masters are available online. So just go and compare them one-to-one, and then go into the research. And of course, we have the most interesting and exciting stuff, but I mean, it's also a personal taste thing, right?
It has to be what's interesting to you. I mean, what gets you out of bed, not me. So, of course, sure.
Exactly.
Yes.
Yeah.
But I think that, sorry? Oh.
Yeah, no, I want to add, like, what I I don't know how much they do that at other students at other university, is that there's really freedom in projects that I am able to choose. So I can just go to almost any professor and say, hey, I find your research really interesting. Do you have any place for me to do some research? And they'll most likely say yes, or say, you're somebody else already went before you. Like, that's what I really like here. But of course, I've been in Leiden for my bachelor's and master's, so I don't know how much that compares to others.
No, I think it's true that, so one thing that is a little bit different in Leiden from other places, I mean, you have places where you have a lot of people working on one thing, and those people, so you immediately recognize that that's a center of excellence for this particular thing. And in Leiden, we have a much more distributed type of research where everybody's doing something different and everything is complementary to somebody else's. And so it's a much more networky type structure, if you want. So I find that is different. The number of different things that we cover is much broader than what you would expect for 30-something staff members that we are. And I think that is actually unique in some sense. Sure. I will say goodbye, and please join the chat and send us all our questions.
Yeah, a very short comment, because in the chat we cannot broadcast. You really need to find us in the chat and ask a question, where we cannot approach you with, do you have a question? It is expected that you ask your question. So please do so. Don't sit back. But that's the idea. If it's too busy, you just need to wait a bit, but you need to ask your questions. So see you there.
Okay. I see Jonas typing something, but I think we have to go. So Jona, will you take it to the chat, or? Okay. Yes, I think so. Okay. Thank you.